morning, good afternoon, good evening. Welcome you all to the Sinha classes. This is Deepak Sinha and you are at the Sinha classes. So today we are going to discuss about the series programming in C, and this is one of the application of nested loop, that is the series programming. So basically in the today's agenda we are going to discuss about the series programming and some more programming also, right? So let me discuss that what we are going to discuss today. Fine. So first thing we are going to discuss about this series programming, that is what will be the how we are going to generate this series, that is sum of n numbers. This will be the first agenda point which we are going to discuss, that is 1 plus 2 plus 3 plus 4 plus 5 till n. If this sum of this number we are trying to add, so how we are going to do the code, right? Okay, so to generate this is there is two options. First one is let me declare a variable like n, fine, and let me declare one more variable, that is sum, to which we are trying to just generate this sum of series, right? And here we can ask user that enter a number up to which you need the addition in series, right? Semicolon to terminate. Before that we need to ask user to enter the number, right? So percentage d, that is ampersand n. Okay, next this variable sum, and I want to just hold the value of this addition of series, right? So the first one is very simple, that the series formula is n multiplied n plus 1 and the whole divided by 2, right? The whole divided by 2. This is a formula, right? So you can print the value. So the sum of series up to percentage d, that is n, is percentage d, that is sum. Fine. So we need to print it, right? So the first one is n and the next one is sum. Okay, terminate it and then try to run it. Yeah, so enter the number up to which you need the addition in series. So let me write 10. Fine. So we want a summation up to 10. Okay, so you see the sum of series up to 10 is 55. Fine. So this is simple formula based, right? But if you want to make it with the help of loop, there is a way, right? So okay, so this I need to delete it, and the same what I am doing, I am using, you see, loop. So integer I equals 1, it will starting from 1. I should less than equals n, because you need to add up to n, right? Plus I, fine. And here what you need to do, simple one, sum equals sum plus I. Now you see, here you need to declare the value of sum initialized to 0. Why we need to declare this to 0? Because you see, if you are trying to add anything to 0, let me show you. If you are trying to add anything to 0, like if I am writing sum equals 0, so if you are adding anything to 0, let me write like this: 1 plus 0, it will be 1 only, right? Give me a moment. Okay, 1 plus 0, it will be 1 only. 2 plus 0, it will be 2 only, right? So anything you are trying to add with 0, it is going to give you the same number, right? So likewise, if you are trying to hold any number after addition, you should declare the variable with 0. Okay, so this here I have written here sum equal to sum plus I. So what will happen? In the beginning, the value of sum is 0 and the value of I will be 1. So the ultimately 0 plus 1, it will be, this will be 1. Next time 1 plus 2 2, 3. Next time 3 plus 4. Likewise, it is going to add all n numbers, right? And finally, you'll get the summation of series, right? Summation of series. So let me run it once again and let me see whether it is working perfectly or not. Okay, it's asking. So let me write this time not okay. Let me write 10 only, right? So 10. You see, the sum of series up to 10 is 55. Fine. Okay, it's 55. I think it's okay. Fine. So if this is okay, now we can go further to the next code, and next code is very simple one. You see the next code. Next code is asking you need to write a sum of series 1 is means 1 square, 2 square, 3 square, 4 square, 5 square till n square. Now it's very easy, right? You know how to do. Very easy one. What to do? Simply this time it's not simply addition of one number, it's addition of square. You see, it's addition of 1 square, 2 square, 3 square, 4 square. Now you see, this is if we are running a loop I, so the value of I is 1, next time it will be 2, next time 3, 4, 5, like n. So what to do? Very simple. Do it I multiplied I, right? So here you need to change simple in the code. You need to do sum equals sum plus I multiplied I, right? And you'll get the answer, right? Very simple. So simple. You see, this time I am again giving 10. So you see, it's the sum of series up to 10 is 385. Oh, we need to change the sum of square in series up to n is this. Now it will give the proper output. Okay, so let me write 10. So it's going to give me the square is 385, right? Next is again very simple. Put the next question. You see, the next question is cube, right? 1 cube plus 2 cube plus 3 cube plus 4 cube up to n cube. Now you know. Now you know what to do. Very simple. Multiply it again 3 times, and here simply we need to write cube, right? And run it. Again the same value I am writing. It's like this. The sum of q in series up to 10 is 3025, right? So I guess now you got the answer to this. All 3 questions is very simple. If you know the answer to the first question, you can go for the second and third as well. There is no problem at all. So let me go to the fourth one. Fourth one is, it is saying 1 plus 1 square, 1 divided, you see here, 1 divided 1 square plus 2 divided 2 square plus 3 divided 3 square up to n divided n square. Again, this is not a big thing to do, right? So this time it's saying it's 1 divided, right? 1 divided, you see it's 1 divided 1 square, 2 divided 2 square. So you need to do this square, and the same should be, the I should be divided by this square, right? Right? You see, 1 divided 1 square, next time 2 divided 2 square, next time 3 divided 3 square, next time 4 divided 4 square, right? So it is sum of 1 divided 1 into 1 plus 2 divided 2 into 2 dot dot dot. I am writing like this, right? This simple message. So let me run it. Okay, the same value I am giving. Okay, you see it's saying the sum of this series is 10 is 1, because you see here when you are writing 1 divided 1 square, then 2 divided 2 square. So what will happen? You see what will happen? In this case 2 divided 2 square, what will happen? It will be 2 divided 4, right? 3 divided 9, then 4 divided 16. So ultimately after everything this part is very negligible, or ultimately this one will, you see, happen. So finally it's an integer value, so it is printing 1. There is no problem at all, right? The next question again very simple one. 1 divided cube, right? So what to do? You know, very simple. Write it here. Multiply I. It is 1 divided. Okay, let me write here 1 once again and multiply 2 once again. Right. So this you see 1 divided 1 cube. Next 2 divided 2 cube. Next 3 divided 3 cube. Right. So let me run it. The same code, simply I am changing, right? So 10, you see, again, you see, when it is going to divide and if this number is an integer, it is going to come very small, a smaller part only. So that's why this value is coming, so nothing to worry, right? Okay, now this problem is bit important one, this one. 1 divided 1 factorial, 2 divided 2 factorial, 3 divided 3 factorial, and so on, right? To solve question number 6, we need to discuss the factorial first. Now, what is factorial? You see, what is factorial? Factorial meaning, if I am writing factorial of 4, you know, it is 4 multiplied 3 multiplied 2 multiplied 1. It will not go up to 0. If you are going to multiply 0, everything will be 0, yeah? Or 1 multiplied 2 multiplied 3 multiplied 4. Any of this logic is okay, either this or this. This is called factorial. Fine. So to discuss this problem, what we can do, we can first learn how to calculate factorial. We can first learn how to calculate factorial. After calculating factorial, we know how to do it, right? So let me discuss the factorial first. Fine. Let me discuss the factorial first. How to do factorial. Now to do factorial, let me write n only. Okay. Okay. Integer n. And okay. Printf. Enter a number to compute factorial, right? Scanf percentage d, that is ampersand n. Okay. Now here I am declaring a variable fact and I am initializing it with 1. Why? I will discuss. Now I am writing a for loop. Integer I equals 1. You know, you need to multiply till n, right? If it is 5, then 1 into 2 into 3 into 4 into 5 into 1 into 2 into 3 into 4 into 5, right? So this loop should go less than equals n. Fine. Then plus plus I. What to do? This time you need to hold it in a variable, and the variable I have initialized here with 1. You see why I initialize it with 1. You see, I discussed you before. If you are multiplying any number, with 1, let us suppose 1 into 1, it will be 1. 1 into 2, it will be 2. 1 into 3, it will be 3. So when you are multiplying any number with 1, you will get the same number. Like when you are adding any number with 0, you will get the same number. So whenever you are trying to multiply and just hold the number, you should declare a variable in the beginning with 1, right? Don't ever try to declare it with 0, otherwise you'll never get the answer. Okay, so fact is equal to fact multiplied what? I. So what will happen? You see, it is 1. So 1 multiplied 1, it is 1. Then 1 multiplied 2, 2. Then 2 multiplied 3, 6. 6 multiplied 4, that is 24. 24 multiplied 5, that is 120, right? So finally you'll get the factorial of 5. And what to do? Printf the factorial of percentage d is percentage d, that is factorial of n is fact, right? So I guess the code is okay. Let me run it. I think we did some mistake. Scanf. Okay. So you see here, scanf misspelling is mistake. Run it. Okay. So we need to calculate the factorial of 5, and we know the factorial of 5 is 120. Just I discussed you. Next time if you are trying to calculate the factorial of 4, it is 24, right? Why 24? It will be 1 multiplied 2, that is 2, 2 multiplied 3, that is 6, 6 multiplied 4, that is 24. So this is how we are going to calculate the factorial, okay? Now the question is not this. Question is we need to just see the series. You see the series. 1 divided 1 factor, 2 divided 2 factor, 3 divided 3 factor, up to n divided n factor, right? Right? So how to do it? How to do it, right? And we need to just get the summation of all this, right? So again, what we discussed earlier, you remember that we need to declare a variable with 0 to get this all sum. And here, what we can do, so for integer, let's take k equals 1, k less than equals n. Why I am doing this? I'll discuss, don't worry. Plus k, okay. Here you see this is fact, but I am initializing it here. I declared there, but initializing here. Why? I'll discuss you, don't worry. You calculated factorial, and here we are going to write sum equals sum plus k divided fact, right? We need to print the like this. Wait a minute, this is starting, this is okay, this is closing, and finally we got the output. Let me try once. So yeah, there was one mistake here. It should not be less than n, right? It should be less than k, right? So now I think it will run properly. So let me write 10, and yes, okay, fine. So you see, the point is when you are going to do like this, so it is 1 plus something, you see it is 0.5 here, again 0 point something. So finally, when you are going to add this all, it is coming around 2, right? It's coming around 2. So this is the code through which we can get the this series. And let me discuss you. You see here integer n, which we entered here, which is 10, right? This loop is up to 10. In every loop, if the value of k is 1, so it is calculating factorial of 1. When the value of k is 2, then this loop is calculating factorial of 2. When this loop the value of k is 3, then it is calculating factorial of 3. So after calculating factorial of a given number like 1, 2, 3, it is adding sum is equal to sum plus k divided fact. You see, when the value of k is 1, so it is writing 1 divided factor of 1, 2 divided factor of 2, 3 divided factor of 3, 4 divided factor of 4. So everything is in sum, and finally we are giving the output, right? So the next question is, I think, yeah, reverse of a number. Now this is again very interesting one, reverse of a number, right? So let me show you what is the meaning of reverse of a number first. Fine. Reverse of a number meaning input is equal to 1, 2, 3. I need output as 3, 2, 1. That is, input is 123 and you need output as 321, right? Now you see, if I am writing 1, 2, 3, if I am writing 1, 2, 3, this is ones, this is tens, and this is 100, right? But if you see 3, 2, 1, right? So this is 1, this is 10, and this is 100. So you see, we need to change the position of number. And this all position number is going to change in a multiple of 10, right? In a multiple of 10, meaning, you see, this is, you see, here, the position is 0, but it is this one, it's coming here, it's 100. So to multiply, we need to multiply this 1 by 100 to reach here. This 2 position is, you see, constant, no problem. But you see the third position, it is 100 here and here it is at 0 position. So we need to change the position of you see number in a multiple of 10. So to do it, what we can do, let me show you what we can do. You see, if I am going to do like this, 1 2 3, if I am going to give a mod of 10, so it will return 3, right? Then what I need to do, 1 2 3 minus this 3 remainder, right? So it will 120. So what we can do, 120 divided 10, then it will be 12. Now you see, from 123 I just taken 3 and now the number is 12. The same thing I can repeat to take 2, right? The same thing I can repeat to take 2. How? Same thing. You see, 12 mod 10. 12 mod 10. It will be 2, right? 12 minus 2, that is 10, right? Then 10 divided 10, that is 1. Now you see, again we did the same thing to take 2 out and you got 1 here, right? Now same thing we can do to take 1, right? So let me show you. 1 mod 10, that is 1. 1 minus 1, that is 0, and 0 divided 10, that is 0. So we need to do it till we are not getting 0, right? So this loop will run till we are not getting 0. Now I think this logic is clear, fine. And what we reverse, and reverse we are initializing 0. So what we can do, reverse is equal to reverse multiplied 10 plus the remainder, right? Remainder, that is 3. So what will happen? It is in the beginning it is 0. So 0 plus 3. The first thing is 3 you'll get, right? The value of reverse is 3. Next time what will happen? You see, next time 3 multiplied 10 plus second value is 2, right? So it is 3 2 32. Next time what will happen? You see, 3 2 32 multiplied 10 plus 1, that is 3 2 1. Now you see, the input was 123, this was the input, and the output which you got is 321. So I hope this is the logic, and it's clear. I guess this is clear, right? If it is not clear, we are going to do code, and in the code it will be more clear, right? So this is the code for reverse of a number, right? So let me code it. The logic is clear. If it is not, we'll see it once. There is no problem at all. So what I told you that take a variable reverse to 0, then n which we need, right, to enter. Okay, and there is one variable to hold remainder r, right? So here I am writing printf enter a number to compute its reverse. Fine. Now scanf %d, that is %n. This is the number which we want to enter to reverse. Now, okay. Now we are making a while loop till n not equal to 0. Why? I discuss you here. You see, we are running this loop till the value of n is not 0. You see here, till the value of n is not 0. You see, till the value of n is not 0, right? So we need to do this loop. We need to run this loop till the value of n is not 0, right? Okay. So while n is not 0, what to do? Simple one. Take the remainder. So remainder is equal to n is our number, n mod 10, right? Then n equals n minus 1. not n minus r, that is the remainder we need to minus. Just see it here, what we did, you see, after calculating this remainder, we are just minusing, you see, n minus r and then n divided 10, right? So same thing I am doing here. Then what to do, n equals n divided 10, okay, and then what, reverse equals reverse multiplied 10 plus r, right, plus r, okay. So a reverse of the given digit is percentage d, that is reverse, right? I think it's okay. Let me run it. Okay, let me run it. So same thing I am writing 1 2 3, let me see, 3 to 1, okay. So I just discussed this logic with you, and this is the output. We entered a number 1 2 3 and you got 3 to 1. To make it more clear, let me run it once again, and this time I am just writing any number, right? And you see sum of digits of a number, you see the sum of digits of a number, meaning the input is 1 2 3, you need to give output 1 plus 2 plus 3, right now. After reverse, this is another problem. So this is very simple. You know that we with this logic we are just taking one digit. So here we are not reversing, no problem. What we can do, here I am writing sum equals 0, and here what I can do, sum equals sum plus r, sum, okay. So you see 1 2 3, the output should be 6, yeah, it's 6. Next, let me learn once again, 1 2 3 4 5 6 7 8 9 and 10. I think 10 it is not going to accept, right, till 9, okay. So it's 45. If it is 10, then it will be 55, but 10 is not going to accept because it will take 1 0, right? So the reverse of the given digit is 45. Fine. So how it happened? Simple one, very simple one. What we did, you see, we just taken this all values one by one and we simply added. We taken this all value and we simply added, right? With this logic I already discussed with you, right? And code is here. There is very minimum change. I have not reverse multiplied by 10. I have not changes its you see place value. Simply I added and stored it, right? So very simple one. Next very interesting question which we can take is sum of cube of digit, right? Sum of cube of digit. You see this one. Sum of cube of digit or sum of square of digit. Now I think you know what we are going to do. So sum of a square of digits is very simple now. It's r. So what we can do? R multiplied r. R multiplied r. Right? It is the sum of square of given digits is percentage d. That is sum. Okay. So let me run. 1 2 3. That is 1 square plus 2 square plus 3 square. 1 plus 4 plus 9. It should come 40. Yes, 40. Right? So what is this? 1 square plus 2 square plus 3 square. Right? Right? Okay. Now if this question sum of cube of digits, so you know what to do. Simple multiplied r, right? 3 times. And here we should change the message also. Last time I have not done it, right? So you see 1 2 3, that is 1 cube plus 2 cube plus 3 cube. So 1 cube is 1, 2 cube is 2 2 4 8 and 3 cube 27, right? So it will come 36. 27 plus 8, what? 27 plus 8 is your 35 plus 1, yeah. You see, sum of cube of digit. Sum of cube of digit means 1 cube plus 2 cube plus 3 cube, right? So this is 27 plus 8, 35 plus 1, that is 36. Fine. Now, in continuation to this problem, there is one very interesting problem that we are calling it as Armstrong number. Let me show you something. When I am going to ask the sum of cube of digit, that is 153, you see it's going to print 153. And when you are just adding the cube of digits, and if the number is same, then we are calling it as Armstrong number, right? 153, it's 1 cube plus 5 cube plus 3 cube, right? So this is 1 plus 125 plus 27. If you are going to add, it will be 153. Likewise, there is one number, there is a number 370, that is 3 cube plus 7 cube plus 0 cube, right? So we are going to do this, so you'll get this number only 370, like 371 also, and I guess there is 407 also, right? So these all numbers are a special number. The cube of all these numbers are same, and then we are calling it as Armstrong number, right? So this we are calling it as Armstrong number. Fine. Okay. So you need to, verify that whether the number is Armstrong or not. In that case, you need to find the sum of cube and you need to verify with the original number, right? So here what I can do, here the value of n is going to distort, right? So I am just declaring one more variable, that is temporary, and I am holding this number just for the okay. And here I am writing if sum logically equal to temporary is an strong number, that is okay, sum is also okay, or let me write temporary, okay, else printf percentage d is not an strong number, right? That is temp. Temp is nothing, it's a copy of n, right? Why I am creating a copy? Because actually while processing everything we are distorting n, means finally n is going to become 0, right? So we need a copy to compare. Okay, so let me see whether it is working or not, right? Comma is missing here, right? So okay, so 153, so it will say 153 is Armstrong number. 370, again it will be Armstrong number. Next time 371, it's again Armstrong number. Next time 407, it's again an Armstrong number. Let me write anything else, right? Like 345, you see it's not an Armstrong number. And one is prime number. So okay, one is prime number. So prime number is nothing. You see, prime number, to calculate prime number, I think you are knowing about the logic of prime number. Let me discuss. If some number, let me discuss about the 3. If it is divided by 1 or the same number 3, right, then we are calling it as prime number. Fine. If it is completely divided by 1 or its own, then we are calling it, like take 5. It will be divided by 1 or 5. You can't divide it with 2 or 3 or 4 completely, right? You can't divide. So this we are calling it as prime number. So how to do code for the prime number? Let me calculate the prime number up to 100, all 100 numbers, right? All 100 numbers. So what we can do, I'm telling you what we can do. Let me take a prime number like 7. Let me take a prime number 7. Fine. So I'll start dividing from 2 to 7 minus 1, that is 6. If it is going to divide by any of the number, we will say this is not a prime number. And if it is not going to divide between 2 to 6, then finally we are going to tell that this is a prime number, right? So I'll take a loop from 2 to the number minus 1. That if it is 7, then up to 6, right? And we'll see if it is divided, if it is going to be divided, then it is not a prime number, otherwise it's a prime number. Fine? Okay, so how to do the code? Very simple. I'm doing code in front of you so that there should not be any gap between what I'm teaching you and what you are getting, right? So I'm taking n is equal to 100 just to find all prime numbers between 100. This is R to find remainder. Just I'm making a loop from integer I equals 2 because I'm trying to check from 2. 1, if you are going to use from 1, you see, so from 2 till 100. Fine. Plus I want to check all numbers, all prime numbers between 2 to 100. Here I am declaring a flag variable to 0. Why I am declaring this? I'll explain, don't worry. So for, I told you, the number between 2 to the number minus 1, right? So integer j equals, it will always start with 2 and it should be less than the number, right? So j less than I. Now you see, the first number which we are trying to see is 2. So this loop will run from 2 to less than 2. The first loop will not run in any case, but third loop will run, right? So j plus plus. Then now you see, if I mod j logically equal to 0, meaning very simple. You see, if the value of I is 3, j is 2, so 3 mod j will never 0. 3 mod 3 will be 0, right? So but we are not running up to the number. I told you we are running loop. Let us take the 7. So this loop will run from 2 to 6. So 7 mod 2, it's not 0. 7 mod, give me a moment, 7 mod 3, again it's not 0. This will be what? 1. This will be again 1. 7 mod 4, so this is 3. 7 mod 5, so this is 2. Then 7 mod 6, this is 1. You see, nowhere you are getting 0, right? So this number is prime number. Okay, fine. If it is 0, then we are going to change this flag variable to 1, and then we are going to break this inner loop, right? Break, I discussed with you. I discussed it in one of my, you see, session. If flag is logical to 0, then printf %d, that is what? And let me give a tab also. All right, what to print? I. Fine, return 0. I think, yeah, it's okay. So what we are doing, you see, here we are declaring flag to 0, right? If this is going, I mod 0 is going to become 0, then the flag value will be 1 and it is going to break. After this, it is checking if the flag is 0, then it will be prime number. And if in between any, you see, number, the mod is 0, meaning this is not a prime number and the flag will 1. If the flag will 1, this is not a prime number, right? So let us, so let me cut it and it should be out of this loop, right? And now it's okay. Now it's okay. Let me run it. Now you see, so between 2 to 99, these are the prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97, right? So these are the prime number and this is the logic through which we can calculate. I think logic is clear and I have written the code also. You can write code with me, right? So this is all about this session. We discussed around 12 codes today. Yeah. we discuss about 12 codes today, series programming and all, right? So these are the 12 code. We just give me a moment. These are the 12 code we discussed today. Fine. So this is all about the today's session. Next session also will take some series program or something about the coding part that I'll see as per your you see session. We'll see how to do. So thank you, thanks a lot, and we'll meet next session very soon. Till then, take care. Bye bye.